Empirical formulas. What is an empirical formula? This is a formula with symbols of the elements in a compound containing subscripts showing the smallest whole number ratio between the different atoms in the compound. Again, the most important words here are smallest whole number ratio. What is the purpose of an empirical formula? To determine the molecular formula or analyze compounds. What do I need to find the empirical formula? You will either be given the masses of the individual components or percent composition of the compound. You will need at least one of these things to find the empirical formula. How do I calculate the empirical formula? There are 3 steps. The first step is to determine the number of moles of each component present. One side note. If you are given percent composition, assume this is out of a 100-gram sample and change percent into grams. Change percent into grams. Once the number of moles have been found, determine the mole ratios present in the compound. If you have a number that is close, round to the nearest whole number. However, if you have a number near 0.5, multiply by 2 to obtain a whole number. If you had 0.33 or 0.66, multiply by 3. 0.25 or 0.75, multiply by 4. 0.166, multiply by 6. The last step, write the chemical formula using the mole ratio as the subscripts. Now, one note before we move on with step 2. You may want to add here, divide by the smaller mole number. Now, I realize some of this may not make much sense to you, so we are going to work through a couple practice problems to make sure you're able to do this. At this point, I would have my notes next to the practice worksheet. A sample contains 29.3 grams of carbon and 4.92 grams of hydrogen. Determine the empirical formula of the sample. My first step is to determine the number of moles of each component present. So to do step 1, I'm going to take 29.3 grams of carbon and I'm going to convert to moles of carbon. So I get 12.01 grams of carbon off the periodic table, 1 mole of carbon on top. I get 2.43963 moles of carbon. Then I will likewise take my 4.92 grams of hydrogen, not 12.01, that was for carbon. .008 grams of hydrogen, 1 mole of hydrogen on top, and I get 4.88095 moles of hydrogen. You'll notice I do not use diatomics because, again, I want the smallest whole number ratio. Step 2. Here, I need to determine the mole ratios present in the compound. In other words, I will divide by the smaller mole number. If we look, carbon is my smaller number. So I have 2.43963, and the number continues, divided by itself, and I get 1. I'll take my hydrogen value, 4.88095, divide by the smallest number, which was carbon, and I get 2.0006, goes on and on, so it's roughly close enough to 2. Step 3. Write the chemical formula using the mole ratio as the subscripts. Carbon has 1, hydrogen has 2. We don't usually write a 1, so it's CH2. And that is my final answer. Another problem. A compound containing only nitrogen and oxygen is 25.936% nitrogen by mass. Determine the empirical formula. Well, there are a few things we have to remember here. Number 1, I can change percent to grams. And I can assume this is out of a 100 gram sample. I'm going to subtract because this was my amount for nitrogen, and I need to get my amount for oxygen, which is 74.064 grams. Step 1, convert to moles. Remember, I'm using molar mass from the periodic table, and I am not using diatomics because we want the smallest whole number ratio. Step 2, you're going to divide by the smallest number, which we know here is nitrogen, so I'm going to divide both numbers by this number. Here I get 1. Here I get 2.5006, which is about 2.5. Now here's where my note from step 2 comes into play. You'll notice that for oxygen we got about 2.5, but an empirical formula is the smallest whole number ratio, so I cannot have a decimal. So what I need to do is take both of those numbers times 2 to get whole numbers. So again, nitrogen had 1, oxygen was 2.5. I'm going to multiply by 2, and I distribute that 2 to both numbers, and I get N2O5. That is my step 3. Again, if you get a number that is 0.5, you'll multiply by 2. If I were to get 0.33 or 0.66 repeating, I multiply by 3. 0.25 or 0.75, I multiply by 4. 0.16666 repeating, and I multiply by 6. One last note. Is C4H8 an empirical formula? Hopefully you said no, because remember, an empirical formula is the smallest whole number ratio, and this is not the smallest whole number ratio. What is an empirical formula? Again, keep in mind, it is your smallest whole number ratio. So what would be the empirical formula for C4H8? Or what will we do? We weren't given the two things that we need according to the notes, so the only other thing that we can do is to reduce. I will divide by 4 and we'll get CH2. Now you're probably wondering, wait, I thought we did not reduce covalence, and you're correct when we use the molecular formula. But an empirical formula is always the smallest whole number ratio, so you will reduce if you are not given anything else in order to calculate the empirical formula.